Hello and welcome to pH Chemistry. Today's explainer is exothermic reactions, energy out, surroundings warmer. By the end of this, you'll know how to identify one, what's happening with the bonds, and why delta H is negative. An exothermic reaction transfers energy from the system to the surroundings, usually as heat. The temperature of the surroundings rises. Examples: combustion, neutralisation, oxidation, hand warmer pads. The energy released comes from bond making, giving out more energy than bond breaking absorbed. Three things. 1. Heat is released. The surroundings warm up. 2. The delta H is negative. Energy leaves the system. 3. Products sit at a lower energy level than reactants on a reaction profile diagram. Common slip. Assuming exothermic means hot, the substance might not feel hot, just warmer than before. The defining feature is the direction of energy flow out of the reacting mixture and into the surroundings. Quick example: burning methane. CH4 plus 2O2 goes to CO2 plus 2H2O. Heat is released, which is classic exothermic. Or HCl plus NaOH, mix them and the beaker's temperature rises a few degrees. Both are exothermic. Right. If any of this is going to stick beyond this video, drop into phmaths.com. You'll find a free 4-week GCSE higher revision planner ready to download, plus the mastery workbooks across maths, physics, biology and chemistry. One for every higher topic in each of the subjects, with every answer fully worked and every common slip flagged. Some simple explanations, serious results. See you next video.